Okay, so this is a short video on concept 52. If you were absent, I would strongly suggest that you check in with a peer or with me regarding any of the information in this video, okay? So I'm gonna briefly or quickly go over this, and if you were here on Friday or when we covered this, go ahead and just skip forward to where we left off. So angles in standard form, again, are the ones that move or are measured opening from positive x-axis here, and then you open counterclockwise and you get some angle measure. So again, using this little diagram here, I know that this here is a 90-degree angle, so if I open from here 0 up to here, this angle would be 90 degrees. If I open another 90, it'll be 180 because it's a straight line. And then if I open another 90, it'll be 270 degrees. And then finally, if I open another 90, you just made a full rotation. It's 360 degrees. Now it doesn't stop there. You can keep going. If you add another 90 degrees, you'll be at 450, and then another 90, and so on. If you do another rotation, it'll be 720. So yeah, you can have overlapping or what appear to be overlapping angles. You can keep going, so as long as you denote that you kept going, so that you have an angle that goes past 360. So the ray on the x-axis, that's this guy, where it starts to open from, is the initial side. Okay, where it opens to, so this array here, that's my terminal side. Counterclockwise rotations are positive measures. If you open clockwise, if I were to open this way, this would be negative measures, and of course one full rotation would be 360 degrees. So drawing angles, you can sketch 75 degrees, so that's not quite all the way to 90 degrees. It would be somewhere before that. So again, sketch as accurate as possible. Please don't be sloppy. Okay, that would be 75 degrees there. Negative 160, I'm opening counterclockwise, so past negative 90, but not quite negative 180, so somewhere there. 430 degrees, here's my initial side, here's 0 degrees. I go all the way, it'll be 360 degrees, and then not a full another 90 degrees right before that, so 430 degrees would be somewhere there. My arrow here, of course, denotes that I did one full rotation and I went past it. Okay, so that's 430. Radian versus degree measures. A radian is a unit of angle measure based on arc length. 1 radian is defined as the angle measure of an angle formed when the radius is equivalent to the length of the intercepted arc. Recall that the circumference of a circle is 2 pi r. Therefore, 360 degrees is equal to 2 pi radians, and 180 is equal to pi radians. That was a lot. Okay, so it's my understanding that it probably wasn't covered, the concept on arc length. So basically, what you need to know is it's a simple idea that if you have a circle, the measure around the circle, that's my circumference. I have 2 pi r. This can also be represented as 2r pi or pi times diameter, pi d. But 2 pi r, and arc length is only a part of the entire circle. So this here in red, that would be an arc length there. Okay, so again, only part of a circumference of a circle. So it says the radius is equivalent to the length, is equivalent to the length of the intercepted arc. So right here, here's my radius. It's equivalent to the intercepted arc. Okay, so therefore 360 degrees, if I go all around, okay, that's equivalent to 2 pi radians. Very important. 360 degrees of a measure is 2 pi. Therefore, half of it, only half a circle, 180 degrees, is pi. Okay? To convert from degree to radians, here's my formula. Okay, I have degrees. My given degree measure, you're going to multiply by pi over 180. if you're given radian and trying to go to degrees, you're going to multiply by 180 over pi. How do you know what's what? If you recall from your science class or in the past in math classes, you should have covered a concept that had to do with unit conversion. So for example, if I'm trying to go from inches to centimeters, you would multiply that given inches measure times the centimeter, because you want centimeter, and you would put inches in the denominator. How many centimeters are represented in an inch? That way the inches would cancel and you get your answer in terms of centimeters. Same idea. You're given a degree measure, pi over 180 degrees, because the degrees would technically cancel, and you get your radian measure. Radian measure, 2 degree, again, times 180 degrees over pi radians. The radians would cancel, and that gives you degree. Maybe I should have started. I apologize for that. Okay. The radian measure is usually in terms of pi. That's why the radian and the pi would cancel, because you get rid of your pi, so you get a degree measure. Again, radians are usually in terms of pi. So what you have here is some examples, right? From 4 through 6, you're going from degree to radian, and then from 7 through 9, you have radian, and you're going to degree. So go ahead and just pause the video, write these in, and then let me know if you have any questions or confusion regarding what's going on. Okay, just make a special note, just like memorize, right, when it's pi over 180 or 180 over pi. Next, we have coterminal angles. The idea here is, well, let's read first. Angles in standard position with the same terminal side are coterminal angles. Give 2 coterminal angles for each given angle, one positive and one negative. So what is a coterminal angle? Okay, if I'm given this angle here, okay, so again, it's in standard form, right? I'm opening counterclockwise, so I have a positive 40 degree measure here. Okay, so if here's my initial side, here's my terminal side. If I add 360 degrees to this ray, okay, this ray here, the terminal side. If I add 360 degrees, I land right back where I was. Here's my initial side. If I would have added 360 degrees, I also land right back where I'm at, and this would be equivalent, this angle, right, because I added 360 to each ray. The angle that I land on, or what it looks like, it looks exactly like this one, right? It opens the exact amount, 40 degrees, but I did a full rotation onto it. So 40 degrees plus 360 would be 380. So the 380 degree angle measure will look the exact same, like visually, to this angle 40 degrees in standard measure. So that's what it is. You can also subtract 360 degrees, right? You go if you go clockwise, and you'll see that the resulting angle looks very similar. So that's all what a coterminal angle is. So you add or subtract 360 from the given angle. And of course, there's technically an infinite amount of coterminal angles to a given one, because you're not limited to adding or subtracting 360. You can add 720, right? Because that would be 1 rotation, 2 rotations, and then you still have the same ray. And then same goes for the initial side, 1 rotation, 2 rotations, and you'll still have the same one. So 40 degrees plus 720, 2 rotations, would be 760 degrees. So the 760 degree angle measure would look just like these rays here. So again, you don't have, I mean, that's an important thing to know, but for our sake, if you're just being asked to find coterminal angles, you would just do given the angle plus and minus 360, and then those are your 2 coterminal angles. If you're given a radian measure, you would have to add the full rotation, but in terms of radians, right? And we know this, right? A full 360 degree rotation is 2 pi. So you add and subtract 2 pi from a given radian measure, and then same Same goes for this example. The confusion in class was how do I go from, well, this expression here to the answer. Again, I have to have the same denominator, so this is 2 pi over 1. I multiply top and bottom by 18, and then, you know, I got 36 pi over 18, and then I was able to combine them, and I got 49 pi over 18. Same goes when I subtract here. Same goes here. Multiply top and bottom by 9. I get 18 pi over 9. 14 pi plus 18 pi, 32 pi over 9. Same goes when I subtract here. Okay, reference angles. So, okay, fine, I'll just show you. For an angle, theta in standard form, the reference angle is the positive acute angle formed by the terminal side and the x-axis. Sketch and find the reference angles for each angle. So, when I was younger, this was something that at first confused me, because, you know, I would open the angle and then I wasn't sure what would be the reference angle. Was it going back this way or was it going this way? Because, you know, you got the terminal side and you can go either or. So what it is, and I underlined it in blue, okay, here's the key word, positive acute angle. Okay, that gives it away. So if you ever open, so for example, this first one, 225 degrees. So if you open 90, 180, here's 225. Okay, how do you know which is the reference angle? Do I keep going this way or I go this way? Again, positive acute, double underlined. Okay, acute is less than 90 degrees. So I would have to take this measure to the x-axis. This would be the reference angle. How do I know what it is? Well, 225 opening to there minus 180, because I only opened to there, that would give me this resulting angle here, and that is 45 degrees. Here I have negative 310. So if I open going this way, that would be negative 310. And again, how do I know if I'm going this way or this way? Positive acute. So I have to go finish it right here. And what is this? So remember that it's positive. The idea here is you might be just, you know, handy with looking at these numbers. You know that you're missing 50 degrees from going the full rotation, so then you know that this angle has to be 50. However, it's positive. Okay, so it's a positive measure, so it would be positive 50 degrees. Another way to look at it would be negative 310. So again, I open all the way to negative 310, but if I add 360, it would take me all the way back to it, and then I know that this difference here, right, negative 310 plus 360, that gives me the reference angle 50. 16, I'm giving a radian measure. You're going to want to convert it to what, to the degree measure, and then sketch it. So I have positive 120 degrees right here. Here's my terminal side, and then my reference angle would be here to the x-axis, so right here. So how do I find it? Well, I know that this is opening to the x-axis here would be pi, right, because the whole rotation is 2 pi, half of it is pi. But if I subtract the radian measure here, I get negative 2 pi, sorry, I get pi minus 2 pi over 3, because again, the whole thing, or opening from the initial side here is pi. This is 2 pi minus 3, so pi minus 2 pi over 3 gives me this measure here. So that's the expression, and I would get pi over 3. Again, pi over 1, multiply top and bottom by 3 pi, and then you can subtract and you get pi over 3. Okay, next part, I get, we go into trig functions. Okay, it says, let's see, okay, it says, let theta be an angle in standard form and p of xy be a point on the terminal side of theta. The distance from P to the origin R can be found using the formula, and then here's the formula, okay, x squared plus y squared is equal to r squared, the Pythagorean theorem. So my little diagram here, okay, I have an angle being formed opening from theta. Okay, so here's my initial side, here's my terminal side. P is on the terminal side, so it's right here. Here's my terminal ray, there's P. The distance from P to the origin, so from P to the origin here, okay, can be found using this formula. Now, why this formula? Well, it's just like plotting, right? So if P is on the terminal side and P is x comma y, to find point P, well, it's a horizontal shift from the origin, right? And then a vertical shift from there, and then that lands you on P. So then you can say that the triangle, the right triangle that gets formed to P is x, the horizontal shift, and then y would be your vertical shift. So then r would be x squared plus y squared is equal to r squared. You have a right triangle. So it is the Pythagorean theorem. Now, using this idea, this idea here, I can use my trig ratios, right, to find or solve these type of right triangles. So sine theta, and I underline in red because it's very confusing. Sine theta, you would think you're using this, but then it's like it's an open space. No, we're talking about this red angle here from the origin. So sine theta would be y opposite, right? So SOHCAHTOA, opposite over hypotenuse, so y over r. Cosecant theta, that's my reciprocal, so r over y. Cosine theta, it's adjacent x over hypotenuse r. So I have x over r, then secant theta would be reciprocal. Tangent theta is y over x, opposite y over adjacent x. Cotangent would be reciprocal x over y. So for my first example, I have, it says, I have 0.5 comma negative 2 is a point on the terminal side of theta in standard form. Find the exact values of the trigonometric functions of theta. So I plot 5, negative 2 in my little diagram here. So I land where it's in red. That's 5 comma negative 2. So again, from the origin, I know I move phi to the right, so you can just say that the right triangle that gets formed by plotting P is the horizontal, thanks to my x shift here, would be 5, and then the vertical would be 2. Not negative 2, positive 2, because measures cannot be negative, right? So it's 2 even though I move negative 2 down. For the sake of P, yeah, it's negative 2, but the measure, the side of this right triangle, is just 2. So I use Pythagorean theorem given the two legs of this right triangle to find the hypotenuse, and then, you know, when I do that, I get this here. I get r squared is equal to 29, so therefore r is square root of 29, and that's why I have square root of 29 here. X and y, again, given from my point P, is 5, negative 2. These are the values I'm going to use when I take my trig ratios, okay? Not the ones given here, because then that throws off this guy here, okay? So we're using in points in relative to point P on the coordinate plane. So I'm using these here. So these are it. Just go ahead and show you. Okay, so this is what I have. Just a reminder, you do not want a radical in the denominator, so you would have to multiply top and bottom by that radical, and then you get this expression here. Same case here, I got this expression here. The reciprocals, right, you can just flip these and then you get something that's possible. But yeah, pause the video, let me know if there's any confusion, but hopefully it's pretty straightforward from here. And that wraps up concept 52.